This section is about solving equations with absolute values. Now, what is the absolute value, again, of a number? The absolute value, if I draw the real line, and let's say this is the origin, the absolute value of a number x, maybe x is there, would be its distance to the origin. Distance to the origin, to 0. Okay? So for instance, if I take the number minus 4, how far is minus 4 from 0? It's at a distance of 4. So the notation for absolute value is this. So the would say the absolute value of minus 4 is 4. Same goes if I have 6. What's the absolute value? It's 6, because the distance between 6 and 0 is 6. So it's the absolute value of 6 is 6. So in general, if I have a number x, its absolute value is x if x is positive. But if x is negative, what is the expression that gives me the absolute value? Well, let's think about this. If it's minus 4, the absolute value is 4. If it's minus 6, the absolute value is 6. So that 4 here, that's the opposite of the number inside the absolute value, right? It's the opposite of minus 4. What's the opposite of minus 4? It's minus 4, isn't it? What's the opposite of minus 6? It's minus 6. So in this case, the absolute value of x is minus x if x is negative. And it's not because I have a minus here that the expression is negative. Remember, here if I have a negative there and another negative there, double negative means that it's a positive number. So in all cases here, x and minus x are positive numbers in their respective cases. Now we are going to solving equations with absolute value. Now there are 3 cases that can occur. Either I have the absolute value of something is equal to a positive number. Okay? Well, if it's equal to a positive number, okay, that means that the distance to 0 is positive. So there are 2 numbers that can satisfy this. So let's say that number is 7. I have 2 numbers that are a distance of 7 to the origin. So in this case, I would have, okay, so case 1, I have 2 solutions to this equation. Case number 2, the absolute value of something is 0. So what number is at a distance of 0 to 0? Well, it's 0 itself. So that would mean that the number I have here is equal to 0, or the expression, whatever. I would have 1 solution. In case number 3, the absolute value of my expression is a negative number. Now what number would be at a distance at a negative distance to 0? That's impossible, right? You can't have a negative distance. So there are no solution in that situation. So let's take a look using the following examples. We're going to solve, let's say we're going to solve x equals to 7. Okay, so we're trying to find numbers that are a distance of 7 to the origin. Right, that's easy, right? That's 7 and minus 7. So there are 2 solutions. We're in case 1. X equals 7 or x equals minus 7. 2 solutions. If I write absolute value of x is equal to minus 7, well, what number is at a distance of minus 7 to the origin? There are no such numbers, so no solution here. So we're in case 3. What number has its absolute value equal to 0, that means its distance to 0 is 0. That means x must be 0. So there's one solution here only. So we're in case 2. Okay, let's make this a bit more complicated. Let's say I have x plus 1 equal, in absolute value, equals to 7. So I've got the absolute value of something which is 7. There are two possible cases. Either that number is at 7, so that number, or that expression x plus 1 is going to be equal to 7, or it's equal to minus 7, because both of them, both 7 and minus 7, are at the distance of 7 to the origin. So x plus 1 it could be 7, or x plus 1 could be minus 7, in which case here, if I solve for x, I've got two linear equations to solve for x. It's linear because what's inside the absolute value is linear, but if I had a quadratic, I'd have a quadratic equation to solve. So x would be 7 minus 1, 6, and here I subtract 1, minus 8. And I have the two solutions that I needed. And what you can do is replace, right? If you replace x by 6, you see it works. If you replace x by minus 8, you see it works. So you can check your answer in the end by substituting your answer. Let's take another look at something a bit more complicated. So I've got 5 times absolute value of 2x minus 1 minus 4 equal to 26. So our goal is eventually to write it as absolute value of something equals to a number. And then after that, we can decide which case applies above. So to do this, what I need to do is get rid of the 5 and the 4, minus 4 on the left-hand side. So I first get rid of the minus 4. So I add 4 on both sides, and then I get rid of 5 by dividing by 5. And now I have absolute value of an expression equals to a number. That number is positive, so it means that I have two solutions. Either 2x minus 1 is 6, right? The distance from the origin is 6, so that means the number could be 6, or that number could be minus 6. And then I just solve for x. So 2x equals 7 here, and x is 7/2. That's my first solution. And over here, 2x is going to be minus 5. X is minus 5/2. So two solutions, because I had an expression equal to a positive number. Now I realize what I told you initially is not completely true. These cases, they're actually correct if what's inside the absolute value is a linear expression. So just show you what I mean by that. If I change what's inside the absolute value to something that's like a quadratic function, let's say I have this, x squared plus 8 is equal to 6, right? That would mean x squared plus 8 is either 6, or x squared plus 8 is equal to minus 6. And if I subtract 8 on both sides here, I'm going to get minus 2, and here I'm going to get minus 14. And those two equations are impossible to satisfy, because if I square something, I'm going to get a positive, right? So no solution here, and no solution. So even though I have a positive here, well, I have two cases that could work, but they don't. Like, neither of them has a solution. Okay, so in this situation, even though I have a positive number equal to an absolute value of something, that I have no solution. So it can become very tricky if what you have inside is not a linear function. But you'll see that in the exercises given in the book, everything is linear, so so these three cases will actually work out. So you'll have two solutions if what's inside your absolute value is positive, one if it's equal to 0, and no solution if it's a negative number. This is actually true all the time, by the way, right? So no matter what it's inside, the absolute value of anything can never be negative. This is also correct. Well, if you have a quadratic inside, right, your quadratic equal to 0 may give you more than one solution. Could give you two solutions or even no solution at all, right? So if you have, I don't know, absolute value of x squared plus 1 is equal to 0, well, that means that x squared plus 1 has to be equal to 0, but we know that's impossible, right? Because x squared would have to be equal to negative 1. So, yeah, so it could be very tricky if what you have inside the absolute value is not a negative, is not a linear function. So just be aware of that. Okay.